Hi everyone, welcome back to our channel where we discuss everything IGCSE Mathematics. So today we will be going through the entire additional mathematics paper 2. The taken from the year 2022 is the May-June paper. The code number for this paper is 0606/21/M/J/22. Now, before we start, please remember the handwritten solution for this paper. This PDF file will be available for download from our website. Please feel free to download it as easy reference while you walking through this paper with us. So, without further ado, let's see how we can do this paper here proficiently. Let's look at the first question. So we are told to solve for W, which is the power in the power form of this index form here. So what we need to do is essentially to ln both sides, because in order for us to solve for W, we need to bring it down, right? So ln 5, W minus 1 equals to ln 12. So bring the W minus 1 down, minus 1 is equals to ln 5 equals to ln 12. All right, bring it down. So in this case, what we have is just bring this down here. Then once we are done, just divide both sides by ln 5, with ln 12 divided by ln 5. Then we have got W equals to ln 12 divided by ln 5 plus 1. Right? So key in calculator, here, what we have is a ln 12, ln 5 plus 1. Will be 2.5439. So this is 2.5439. This is 2.54. Okay, 2 decimal places. There you go. That's pretty okay. Then we look at the next part, which is solve this equation and here. Now, don't get too nervous about this. Just take note that this could be changed to a quadratic form. So essentially, look at this carefully. You have got this 2, 1, and a constant here. So this part here, what we could rewrite it into is this form here. X a third square minus 5x about a third plus 6 equals 0. Okay, what we could do is if you are not comfortable in this form, we could just use the substitution. Let y equals to x 1/3. All right, so this is y square minus 5y plus 6 equals to 0. This will be y minus 3 and y minus 2 equals 0. All right, so y will be 3 or 2. Obviously, we need to solve for x. So solving for x will mean that we need to change our y back to x 1/3 is equals to 3 or 2 cube or 2 cube. So we just cube both sides of the equation here. So if this is just cube. Okay, then what we get is essentially x is equals to 9 times 3 is 27 and 8. Okay, so that's how we do this question here. Let's look at the next one, which is write 2 log x and log x plus 6 log 3 as a single logarithm to base of. This is already base of 10. So what we're going to do is, first of all, is to understand that in order for us to use the logarithmic laws, we need to make sure that this is 1. So we're going to bring these 2 up here. So it's lg x2 log, then after which this case here, remember bracket is free. The problem with working is usually students forget to bracket them, and the downfall is that there are a lot of careless mistake there. So you just be careful with that. This is log a plus log b, which is log 3 multiplied by x plus 6, right? So this is a plus b, so just multiply them. Then after which we have log x squared equals to log 3x. Just distribute it in. Should I distribute? I'll just leave it there. Okay, I'll just leave it there as 3x plus 6. Okay, then this is log a minus log b. So we're just going to take log a minus log b is log a over log b. Okay, just leave it. So this is the single logarithm to base of 10. Single logarithm. So hence, solve this equation here. We know that this over here will be changed to log x squared 3x plus 6 equals to 0. So just change this to the index form. We know 10 to the power 0. So 10, this is base of 10. So 10 to the power 0 is equals to the term inside here. So it's 10, 0, x squared over 3x plus 6. Okay. And we know 10 to the power 0 is 1. So this is 1. So once we get that, we're quite okay. X squared. Then we're just going to solve this plus maybe just cross multiply. So x squared 3x plus 18, x squared minus 3x minus 18 equals 0 is x minus 6 and x plus 3. So hence x is equal to 6 or negative 3. Okay. Let's see, do we need to, okay, we need to reject negative 3 because we can't have, so reject as x has to be bigger than 0. X plus 6 has to be, x plus 6 has to be bigger than 0 as well. But we can't have a negative portion there, right? So that's it. We can have, we reject that. Then we know that x is equals to just 6. So for, we have to always check the solution, especially for this kind of equation here. All right, because log is defined where not all of x is accepted in this equation here, right? It has to be a positive value. So let's look at the next part. So next part will be the variable x and y are such that when the cubic root of y is plotted against x squared, the straight line passes through the point 9, 8, and 16, 1 is obtained. Find that y as a function of x. Okay, great. So what we need to understand in this case is essentially we just try and find y equals to mx plus c. Okay, capital Y x, where our capital Y is a cubic root of small y, and our capital X is actually x squared. Okay, great. We don't think about because we have 2 points here, so the 2 points we are able to find the equation of line without we have ample information, we have enough information to be able to solve the m and the c here. All right, so the m will just be y1 minus y2, so we could just take 1 minus 8 over 16 minus 9. That would be minus 7. 16 minus 9, that would be 7. What we get is negative 1. Then we could substitute this in. So we have y is 8. Then m is negative 1. X is 9 plus c. So we can solve for the c as well. So 8 plus 9, which is actually 17. So equals to y is equals to negative capital X plus 17. All right. So now we have got the linearized form here. So now we replace it back. Now we replace our cubic. So y is capital Y is cubic. Y is given by minus x squared plus 17. All right, find y. So cube both sides. Y is equals to 17 minus x squared to the power 3. Okay, so that's how we've done this part here. Let's look at the subsequent one. The polynomial of px mx cubed minus 17x squared plus nx plus 6 has this factor here. It has a remainder of negative 12 when divided by x plus 1. Okay, so find the remainder when px is equals to x minus 2. So essentially what we need to find is the value of p by using the remainder theorem, p2. Right, that's all we need to find. But we are told that there's a factor. So essentially, if x minus 3 is a factor, okay, we know that p3 is 0. The remainder is 0. That's it. And it has a remainder of minus 12 when divided by x plus 1. So essentially, a remainder of 12 when divided by x plus 1, meaning to say p minus 1 is minus 12. Okay, so you just let this be 0. x equals to minus 1, replace it in, and these are the two things that we know. So we have these two equations to start with, which makes sense because we have two unknowns in our polynomial there. Okay, so this case, once done, I'm going to just replace it in. So this case here, P3 will be m3 cubed minus 17 3 square plus n multiplied by 3 plus 6 is equal to 0. This is the first equation I have. So 3 to the power 3 will be 27 m. Then 9 multiplied by 17 would be minus 153 plus 3n plus 6 equals 0. So I'm going to bring the minus 153 and minus 153 plus 6 will be minus 147. So I'm bringing over is 147, and this is 27m plus 3n. 147 is divisible by 3. Okay, so what I do is just divide by 3 throughout. I'm just going to divide by 3. Then the whole thing here will just be 27 divided by 3 will be 9m. This will be n, and this 147 divided by 3 will be 49. Okay, so I got one equation here. The other side will be the remainder of 12 will be remainder of minus 12, negative 12, sorry. So I'm going to replace this into px, so that will be m minus 1, 3 minus 17 minus 1 square plus n minus 1 plus 6 equals to negative 12. This will be minus m minus 17 minus n plus 6 minus 12. Then what we get is minus 17, so plus 17 minus 6. Okay, then this is minus n. Negative 12 plus 17 minus 6 will be negative 1. Great. Now what this is, we could just make n a subject and just replace just from here, n is equals to 49 minus 9m. So replace 1 into 2, replace 1 into 2, or we could use, actually don't know, we can use elimination method. So I'm just going to add both sides. So 1 plus 2, because you could see that n minus n will be 0. So that will be nm minus m equals to 49 minus 1. Maybe I just rewrite this. 9m plus minus m, because plus n plus minus n will be just cancelled out, just 0 pair. 49 plus minus 1, that will be 48. 8m, so m is equals to 48 divided by 8, will be 6. Then after which we know n is equals to 49 minus 9 multiplied by n. There will be minus 5. Okay, n is negative 5. So we know that px is given by m, which is 6x cubed minus 17x squared minus 5x plus 6. We need the remainder of, so hence the remainder, the required remainder is P2, right? P2. So P2, replace it in 6, 2 cubed minus 17, 2 square minus 5, 2 plus 6 by remainder theorem. 6 multiplied by 8 minus 17 times 4 minus 5 times 2, which is 10, plus 6. Be negative 24. All right, so that's how we do this part here, this question. Let's look at the second part, which is write down in ascending order powers of x, the first 3 terms in the expansion of 1 plus 4n, and simplifying each term. Okay, great. So this case there, we need the first 3 terms. So 1 plus 4x n. Now, usually what I'll tell my students is for binomial expansion, what you need to understand is there's a pattern to it. All right, so if you need the first 3 terms, you just bracket it as such, the first 3 terms here. I think this is the most intuitive way or easy way to remember. So this will be n, then you put this as 1, 4x. So n 1 and 4x. The first term, second term, n 1 4x, right? Now remember this will be 0. So now once done, now you need to fill up the rest. So you have you always start counting from 0 for anything binomial. So 0 1 2. Then you need to ascend the power. So now power now need to be ascending order as well. So for x will be 0 1 2. Whereas for the 1 will be 2. Oh, sorry, this will be n minus 1, n minus 2, because we do not know what is the end point there. So essentially, what once done, n choose 0 is just 1. So 1, n is 0. This is all 1. N choose 1 is n 4x. N choose 2 will be n minus 1 over 2 factorial, but this is 4x squared. 2 factorial is also 2 as well. Okay, so simplifying this, we know that this is this is this. All right, once done, this will be 1 plus 4nx plus this is 16 is x squared plus 1, then there will be 1 plus 4nx plus 8n n minus 1 x squared. All right, so this is how we do the first part here. After which we need to, in this expansion, we need to find the coefficient of x. The coefficient of x squared is 36032. Given that n is bigger than 0, find the value of n. Okay, so let's see how we can do this. We're gonna do so we're gonna replace the previous expansion here, which is 1 plus 4nx plus 8n n minus 1 x squared. Then I'm gonna distribute this in. I'm gonna find the coefficient of x. Okay, so we know that 1, this will not be power of 2. I'm gonna find the coefficient of x squared. This will not be power of 2 as well when I multiply these two, right? But what we have is this 4n multiplied by x. This will be power of 2. So it's x multiplied by x will be x squared. So you don't need to expand everything out. Just cherry pick the things that you need. So it's 4nx minus s here. Then the next one will be obviously x squared multiplied by 1. Okay, so this case here will be 8n n minus 1 x squared. This will be negative 16n x squared plus 8n n minus 1 x squared. So the coefficient of x squared minus 16n plus 8n n minus 1 equals to 6032. Okay, so this case here, what we get is 16n plus 8n squared minus 8n equals to 0.32. Then what we get is I think, can we divide everything by 8? So I'm gonna divide everything by 8. 6032 divided by 8 is 754. Okay, great, looks good. Divide everything by 8. That'll be easier. Minus 2n plus n squared minus n equals to 754. N squared minus 3n. 754 equals 0. So we could use our calculator and check for the roots here. So go to mode, equation, and then polynomial, and I'm just going to degree of 2 and just find 1, negative 3, negative 754, 29 and minus 26. So what we get is n 29 n plus 26. Okay, so we're gonna get n is 29. Of course, negative 26 because n is bigger than 0. So since n is bigger than 0, all right, that's how we do this part here. So let's look at the subsequent one. Find the term independent of x. So this case here, what we get is remember we put it in the general term form. So this case will be 10, then this will be x over 2, and the second term will be 8x4. All right. Now remember, if this is r, one of it will be r, regardless which will be r is fine. So I'm going to let this be r, then this will be 10 minus r. Okay, the other one will be 10 minus r. So this is a general form. So when we expand this will be our general form. Okay, so general form, you just write this in general form, general term. So this case here, once I'm done with this, what I'm going to do is actually just try and use indices to separate the x and the constant out. Okay, so we'll look at this 10r half and x. So I'll get, maybe I rewrite this as x 10 minus r to 10 minus r. Similarly for this, I'm going to get minus 8 to the power r. So I'm going to group the negative with the 8 together, and this will be x for r. Okay, so let's distribute them in. So once done, so I'm going to group the x and the x together, and the constant out. Okay, the constant, I'll just leave it 10r, this minus 8r to 10 minus r, whereas this is 10 minus r minus 4r, because this is 10 minus r over x, about 10 minus r over x 4r. So you just minus that, right? Now what we want is actually just to find that r which corresponds to the independent term. So 10 minus 5r. Okay, term independent of x will mean that the power is actually just what do you call it, 0, right? So term independent of x will mean that 10 minus 5r is just 0. So 5r is 10 and r is 2. So the term independent of x would just, we just need to substitute. So hence term is 10 2 minus 8 2 to 10 minus 2. Okay, key in calculator. We'll get is 10, choose 2, multiplied by negative 8 to the power square, then 2 to the power 10 minus 2, which is 8. 45 over 4. Alright, so that's how we do the part B here. So let's go to 6a. A 5-digit number is to be formed from these 7 digits, 0 to 6. So each digit can be used at most once, any number, in any number, and the number does not start with 0. Find the number of ways in which this can be formed. So if 5 digits, 1, 2, 3, 4, 5, we can't start with 0. So we only have got 6 choices here. So this is 6. So after placing one number down, for the subsequent 4 digit, we still have 6 choices, right? Including we can include the 0. So essentially this is 6. Then after placing one, there will be 5. Then another one which is 4, 3. So this would be our answer. 6 multiplied by 6 multiplied by 5 and 4 and 3. So that will be 2160 ways. Okay, that's it. Now find in how many ways of these 5-digit numbers are even. Now the problem with this is essentially 5-digit. 1, 2, 3, 4, 5. You need to break down into cases, because the we can't start with 0. Even numbers are numbers which ends with even numbers ending with 0, 2, 4, and 6, or 6, right? But the problem now is because 0 is a very touchy digit, because if I put this as 0 here, all right, we could have a lot of more choices in front as compared to if I put this as 2 here. We have less choices here because we can't put 0 in the first place, right? So we need 2 cases here, right? So case number 1 is where case 1, numbers ending with 0. Okay, so if I put 0 here, I predefine it already, so the only choice I have is 1. This is predetermined, so it's 1. So if I put a 0 here, it's quite straightforward. Here I can put digit 1, 2, 3, 4, 5, 6. So I have 6 choices here. Subsequently I have 5, 4, 3. Okay, 5, 4, 3. So this case here, what I'll have is 6 multiplied by 4, 6, 5, 4, 3, 360. Okay, case 1 I have 360. Whereas for case number 2, numbers, case 2, numbers ending with 2, 4, 6. This case here, I have 1, 2, 3, 4, 5. So I've got 3 choices behind here. So let's say this is 3 choices. So after laying down 1 digit, 2, let's say I put 2. Just remember, if I put 2 down, for the first digit I couldn't put 0, okay, because 0 is not allowed. So I have 1, 2, 3, 4, 5. I have actually 5 choices here. Okay, excluding last digit and 0. Okay, that's the whole idea there. So if I say I put the 4 down, similarly I have 1, 2, 3, 4, 5 choices. So after putting 5, after taking 2 digits out, right, say the last digit is 4 and 3, so you still can include 0 in, so you have 5 digits left. So this will be 5, 4 and 3. So this would be this case there. 5 multiplied by 5, 4, 3, 3, there will be 900. So hence 360 plus 900, that will be 1260 ways. Okay, so that's how you do this question here. Let's look at part B. A team of 7 people is to be selected from a group of 9 women and 6 men. Find the number of different teams that can be selected which include at least 1 man. Okay, that's great. What I would do if it's at least 1 man, I will take no restriction, number of ways. No restriction minus of number of ways, at least 1 man meaning to say all women. Okay, I do not want all women's team, right? So because I do not want the case where the whole thing is woman, so there's a zone of restriction will be 7 people. 9 plus 5, there are in total 15 people. So the number of ways without restriction will be 15 choosing 7, right? No woman team will be just from the 9 women, we just choose 7. So this will be our answer. 15 choose 7 minus of 9 choose 7, 6399. Okay, 6399 ways. That's how we do this question here. Then let's look at C part 1. Show that n choose 3 plus n choose 2 is this. Okay, great, good. So we're going to start from the left hand side. This is n choose 3 plus n choose 2. So n choose 3, we could rewrite it as n factorial over 3 factorial, n minus 3 factorial plus n factorial over 2 factorial, n minus 2 factorial. Okay, so that's this case there. So what we're going to do is just remember, for factorial is very fun to play with, because for example, if I have got 80 factorial, okay, what I could do is just write this as 80, then minus of 1, then will be 79, 78, 77, and say I want to stop, I want to put a stop to this expansion here. I just put the exclamation mark. So I could stop at any given juncture as long as I put an exclamation mark behind the factorial sign. So it's the same thing as let's say n factorial. So in this case here, you could just n minus 1, n minus 2, and n minus 3. Then whenever you want to stop, you just put the exclamation mark behind the factorial sign. So same thing for this case here. You look between n and n minus 3 factorial, you could expand the n because n is bigger than n minus 3. Alright, similar with this and this. So what I'm going to do is, I'm going to put this as n minus 1, n minus 2, n minus 3 factorial over 3 factorial, n minus 3 factorial. I stop at n minus 3 factorial because I'll get the factorial below. Okay, then I could cancel it out. Then n, similarly n minus 1 expanded, n minus 2 factorial over 2 factorial, n minus 2 factorial. Okay, so this is done. Then what I'm going to do is actually just cancel it. Okay, then cancel this. Then there you go. 3 factorial is just 6. 3 times 2 times 1. So this is n minus 1. This is 6, right? Then n minus 1. 2 factorial is just 2. So this case here, I could just factorize out the n. So I will just factorize this out, okay? Remember, factorization is key. Do not go and expand it. If you expand it, you're going to take longer. So what I'm going to do is, could I just factorize here? I'll just do one step at a time. It's half. Okay. So I factorize out the factorize and n minus 1 out. So here, factorize these two out. Remember to leave a 1 there. After you factorize it out, there will be a 1 behind here. Okay. There's 1. Then once done, I'm gonna just, what do you call it, make it a common fraction here. Multiply by 3, multiply by 3, the 6. The LCM is LCM between 6 and 2 is 6. 6 and 2 is 6. So this case here, n minus 1, n minus 2, 6 plus 3. Okay, what we get is n minus 1, n plus 1, 6. So there you go. We need to show this. What we're going to do is just expand this n a square plus b square for this case here. Difference in square. So a square minus b square. Sorry, a square minus b square. That will be our n square minus 1 over 6, and this will be n cubed minus n over 6. Okay, shown. So for the next one, hence solve this equation here, I think it's pretty okay. Even if you can't do the, okay, maybe I just rewrite this into the term which is required of us. 6. Okay, even if you can't do the first part, what you can do is just replace the given result into this. Okay, so this case there, what I get is n choose 3 plus n choose 2 from the given result will be 1 over 6 n cubed minus n equals to 4n. Okay, this case there, what I'll do is we want to solve this equation. So 1 over 6 n cubed minus n. Do not cancel off the n because n equals to 0 is also a solution, right? Oh, but the thing is, because n is bigger than 3. N is at least 3. Okay, so we could just cancel it out. Okay, great. So 1 over 6n, n squared minus 1, 4n. Okay, so since n is not equal to 0, okay, we could just cancel it out. But we have to be very careful with this, because if when you cancel it out, you just need to make sure that that there's not a solution that you cancel it out. That it is not a solution, yeah, it's not a root. So this 1 over 6n squared minus 1 equals to 4. Multiply by 6 both sides will be n squared minus 1 equals to 24. N squared equals to 25. N is equals to 5 or negative 5. Obviously, we reject this as well, as n is a positive number, at least 3. So n is 5. Okay, this is the only solution there. Alright. Let's look at question 7. So variable x and y are such that y is equals to this equation here. Use differentiation to find the approximate change in y. So approximate change in y, which is this over here, when x increases from 1.9 to 1.9 plus h. So approximate change in y when x increase from 1.9, so here x equals to 1.9, it changes to x equals to 1.9 plus h. This means that the del x is equals to h, right? We know that del y and del x is roughly equals to dy dx. All right, so when x is equals to 1.9, the del x is h. So we want to find the approximate change in y. Will mean that we just substitute 1.9 into dy dx and just multiply by h. Okay, so that's the whole idea there. We need to find dy dx. So what I'm going to do is actually just dy dx first, and that is our first order of business. Just do it. In this case, I'm going to use quotient rule. So 1 plus sine 3x to the power 4 over square root x. Okay, so this case here, this will be my u, this is my v. So u is equals to 1 plus sine 3x4, and after which my v is just square root x, which is x above half, right? So du dx would be, remember, chain rule, outer layer, inner layer. So I'm gonna just differentiate the outer layer with 4. 1 plus sine 3x, 3. Differentiate sine will be cosine 3 cosine 3x. Okay, so this is the outer layer here. Just label it out for you. And the inner layer. Okay, then whereas for the v, what we're gonna get is dv dx is just a simple half x, half minus 1 with minus half, right? So essentially what we get here for dy dx, we know that quotient rule, by quotient rule, is v du dx minus u dv dx. I'm just going to replace everything in. V square, which is square root x square, is just x, and after which v, which is actually square root x, du dx, which is 12 cosine 3x, 1 plus sine 3x cubed. Okay, then minus u, 1 plus sine 3x to the power 4, dv dx, which is half x minus half. So I just put this as half 1 over root x. Okay, that's it. So let me just label everything down. This is our v du dx minus u dv dx, and this is our v square. Okay, simplifying this, do we need to simplify it? H is small, or we could just replace x in. Okay, we could just replace x in, I believe, because we don't need to find anything. So dy dx, so when x equals to 1.9, remember this is in radians, so change your calculator value to radians, okay, before you even keying into calculator. Now here what I'm going to do is just set up mode. Set up, then angle unit, I'll change to radian, then I'm gonna just key in. So x would be 1.9, am I right? Okay, there's a trick to do this because there are too many x here involving too many x. So what you can do is just use the alphabet x, so it's easier. So this case here, I'm gonna just square root x. There's a root x. Then I'm gonna bracket, this is 12 cosine 3x, bracket, then 1 plus sine 3x cubic minus of 1 plus sine 3x, close bracket about 4, and multiplied by divided by, okay, multiplied by half and square root x as well. So just put this down, then the bottom will just be x. Okay, so you just check your syntax error. I need to go and find why is it wrong. So I don't really know what was my syntax error just now, so I just key in everything in again. So you just press enter. Now what you need to understand is we need to store a value of 1 point. So x is 1.9, right? You need to store it in. So it is 1.9, just storage sto, store into x. Just press x here. So you will store 1.9 to x, then you scroll up and you just key in, then you get this value here. So hence from calculator dy dx, x 1.9 will just be equals to 0.65138. Okay, so hence del y is roughly equals to 0.65138 h. We just leave it as approximately 0.651 h 3sf. Okay, so that's how you do this question here. Okay, let's look at question 8 here. So in this question, I is a unit vector due east and j is a unit vector due north. So east and north. So this is north, then this is j. Then east will be I, right? So the distance are measured in kilometers and time is measured in hours. At 9 a.m. in the morning, A leaves a point P position vector of 50. So this is 5i plus 16j, so 5i. So this is OP. Initially, ship A left here. So I'm going to write this as OP is 516. Relative to the origin O, it sails with a constant speed of 6 root 3 on the bearing 120. Okay, great. So meaning to say, modulus of VA, which is the speed of VA, is 6 root 3 km per hour, and the bearing is actually 120. So essentially, if I were to draw this out, this is north and this is 120. This is north 120. This is 120, right? Okay, what I need to do is actually understand that the length of this, the magnitude of this speed here, VA, is 6 root 3. Okay, so I need to find the velocity of A. So in this case here, what we need is actually finding this angle here, which is 30 degrees. You just take 90 minus 120. We're going to find the opposite component, so, and the adjacent component here. The component here will be 6 root 3 sine 30, opposite side, 6 root 3 cosine 30, the adjacent side. Alright, so it's just normal trigonometric ratio Tokaso or Sokato. So this case here, if you want to break down VA, this is in a positive direction because we are moving this direction here and moving downwards. Alright, so VA will be 6 root 3 cosine 30 I minus, because it's going downwards, will be 6 root 3 sine 30 j. Alright, now cosine 30 is root 3 over 2. What we could do is actually, if you're not too sure, you could just put cosine 30. This is a gibberish here, so you sort of know that it's root something, so you just square it, you get 3 over 4. So in other words, the original value is root, you just root this number here, so this is root 3 over 2. Okay, root 3 sine 30 will be sine 30 is half, so this is half, no issue. J, so root 3 multiplied by root 3 will be 3. 2, this is 3, cancel it out, so 3 multiplied by 3 will be 9. Then this cancel it out, 3 root 3i j, 9i minus 3 root 3 j. Okay, that's how you do the part A. Look at part B, find the position vector of A at 12 a.m. So So from 09:00 to 12 in the afternoon is 3 hours. Okay, so OA at 12 p.m. OA is OP plus 3 hours multiplied by the speed, which is VA. OP would be 5, 16, and after which we have got 3, 9 minus 3 root 3. Then we're just going to sum this up. So that's the position of A. Okay, position of A will be 5 multiplied 3 times 3 multiplied 9 is 32. 16 minus 9 root 3. Okay, so position vector of A minus 9 root 3 J. Let's look at part C. At 11 a.m., ship B leaves at point Q with position vector of 29 plus 16 J. So OQ is 29, 16. It sails with constant velocity of this. Write down the position vector of B 3 hours after it starts sailing. So essentially OB would be at time T. OB will be OQ plus the velocity, right? The velocity, so is VB here. So OQ will be 29, 16 plus T. VB would be 0I J, so it's 0 minus 12 root 13. So this case will be 29, 16 minus 12 root 3 T. Okay, so right now position vector, hence position vector of B is equals to 39 I plus 16 minus 12 root 3 T. Alright. Part D, find the distance between the two ships at 12 p.m. So what we need to understand is that at 12 p.m. Vector position of A will be equals to what is already found, which is actually 32, 16 minus 9 root 3. Okay, so position of B, we just need to know that what is a T, right? Because this is 11 from 11. So this case here, from 11 to 12 is actually T equals to 1. 1 hour has elapsed, passed. Okay, so this is 29, T is equals to 1. So this is 16 minus 12 root 3. This is when T equals to 1. 1 hour left. Okay, so this case here, to find the distance, so the distance between distance between A and B is equals to AB modulus. So I'm just going to take OB. This is OB minus OA modulus. So in this case, 29, 16 minus 12 root 3 minus 32, 16 minus 9 root 3. That will be 29 minus 32. So this is 29 minus 32, 16 minus 12 root 3 minus 16 minus 9 root 3. 29 minus 32, negative 3. Then 16. So negative 12 plus 9, that will be negative 3 root 3. Negative 3 square. The modulus will just, we just need to use a Pythagoras theorem here. So it's 9 plus 9 times 3, square root 36, 6 km apart. Okay, 6 km apart. Okay, that's it. The distance between the two ships. Let's look at question 9. So in the question, all lengths are in meters. The diagram shows a water container in the shape of a triangular prism. So this is a triangle here, the base, and after which you just have a constant cross-sectional area. And essentially just elongate it 5 meters. The depth of the water in the container is H. The container has length of 5. Okay, the water in the container forms a prism with a uniform cross section that is an equilateral triangle of side H. Okay, great. So H, this case here, we know equilateral triangle. If this is H, this is also H. X, this is X as well. Side X. This is 60 degrees and this is 60 degrees and these are all 60 degrees. Okay, so that the volume V of the water is given by this. Okay, great. Now the volume V, essentially we just deal with it without putting X in first, right? So what we need to do is actually just write it down. The volume V will just be half multiplied by base, because this area of triangle is half times base times height, then multiplied by 5, right? Right, base area times height. So it's actually 5 over 2 hx. Now for this kind of question, maximization, minimization question, what you need to understand is look at usually the direct entity that you're looking at has 2 variables. So in this case, there are 2 variables here. And what you're asked to show is it only contains one variable. Only contains one variable, which is h. You see that? Okay. H and x are variable because the height of the water, as the height increases, the x will also increase. Okay, so that's the whole idea of being a variable. So what we need to do now is essentially find a constant which relate both of them. So in this case here, what do we have? Oh, we have the geometrical shape, which is the relationship, right, between them. So in this case, this is height. This over here is x over 2. So this case here, we know that by trigo ratio, okay, tangent 60, because look at this triangle here, tangent 60, right, this tangent 60, let me just redraw this. It's tangent 60 here, then this is x over 2, because it's half of the whole entire length, then this is height. So by trigo ratio, we know that tangent 60 is essentially h over x divided by 2. Right, this is how we relate both of the variables. Then once we are done with that, tangent 60 here will be root 3. So in case you do not know, same thing, just put tangent 60 here and you get a gibberish here. Just square it, you get 3. So essentially the original value is root 3. So this case is root 3 here. This will be h over x multiplied by 2. All right. Then what we need is in terms of h. Okay, in terms of, so meaning to say, I need to make my x the subject here to root 3 h. So here, sub 1 into 2, sub 1 into 5v. So this case here, we'll get is v is equals to 5 over 2 h to the h. So cancel it out. What's left is 5 root 3 h squared. Do we need the rational? Yeah, we do. So I'm going to just multiply root 3 here, multiply root 3. I'll get 5 over 3 root 3 h squared. Okay, so I'll do the first part here. So okay, part B, water is pumped into the container at this rate, 0.5 meter cube per minute. Find the rate at which the depth of the water is increasing. So meaning to say I want to find dH dt when the depth of the water is 0.1 meter. Well, what is this, right? So how do we do this? Now the main thing is write down everything, then we're just going to use chain rule. So essentially, water is going in, when water is going in, dV dt in at 0.3 meter cube per minute. Okay, so just write this down. dV dt is given that is 0.5 meter cube per minute. Okay, and just rewrite the rate of increasing increase of the depth. Okay, so dh dt, rewrite in this form here, dh something something dt. Just use chain rule. I usually would just advise students to just keep doing this. So what you need to do next is, because this is what we want to find, so I need to fill up this blank here. So to fill up this blank here, using chain rule, we know that this has to be dv because we were given dv, right? So this is dv, this is dv. So once this dv is done, we know that dv dt is fixed with 0.5 meter cube per minute. Okay, dh dv is what we already found, so v is equals to 5/3 root 3h squared. So even if you can't do this, the first part, you can just use the given result. All right, so you can just use that. So dv dh will just be 5/3 root 3 2h. Okay, so if I want, okay, maybe I just rewrite this 10 root 3 h/3. So this is it. Because now what I need is dh dv. So dh dv is just to take the reciprocal, so it's 3/10 root 3h. Okay, that's that. So once I have got this, what I need to do is just rewrite this as 3/10 root 3h, which is from here, multiplied by dv dt, which is actually 0.5. All right. So at height equals to 0.1, we could actually find dh dt. Do we need the exact value? Find the rate, which I will just leave in exact, I think. So 10 root 3, 0.1 multiplied by 0.5. So 3, so I'm going to key this in the calculator. This whole thing here, except for the root 3 there. So this case here, 3 multiplied by 0.5, which is half, over 10 multiplied by 0.1, 3/2. So this is 3/2 root 3 multiplied by root 3 multiplied by root 3 will be 3 root 3/2 cm per minute. All right. So that's how you do this question here. All right. So let's look at this last question here. So the diagram shows part of the curve y e to the power of half x, which is this curve here. All right, and the curve y equals to cosine 5x, which is this curve here. So, and part of the line x pi/4, this is a vertical line, and the curve intersect at a, and the curve y cosine 5x cuts x-axis at b, and the line x pi/4 cuts the curve, this curve here at D, and also the x-axis at C. Okay, great. So find the exact area shaded region. Okay, great. I think this is not an issue. First thing is to understand that the shaded region is, if we were to project the curve, the e to the power half x curve down to the x-axis, we will get this whole shaded area here, right? And then after which, because we need the shaded area, we need to minus off this area here. So we project the cosine curve down, we'll get this. So what we essentially need to find is the required area. The required area will take the curve projection of the e to the power half x curve minus of the cosine curve below, which is this curve here. Okay, so I think straight off we know that this is, the boundary is 0 to pi/4. So here's 0 to pi/4, and this is the area we need. We need this area here. Okay, so we essentially need this to solve this part here. So this case here, this is where cosine 5x is equal to 0. This is y equals 0, right? We need to solve this. So 5x will be cosine inverse 0. Cosine inverse 0 will be 90 degrees, which is pi/2. Right? So if you're not too sure what this is, what you can do, just key in calculator. Make sure that it's in degree, then you just shift cosine 0. You get 90 degrees. 90 degrees is not in radian, so you need to change this to radian by divided by 180. It'll be half pi. Okay, so it's half pi. So x is equal to pi/10. So this case here, this guy is pi/10. All right. So what we need is from 0 to pi/10 over here. Great. So this case, the required area will be from 0 to pi over 4 ex to the power half dx minus of 0 to pi over 10 cosine 5x dx. That's what we could do. So then integrating this shouldn't be issue, just ex over 2 divided by the coefficient of x, which is half. Remember to divide by the coefficient of x, which is half. Then this will be pi over 4, 0. Then this would be integrating cosine 5x will be sine 5x divided by 5 pi over 10, 0. Okay, that is pretty okay. So this case will be e pi over 4 divided by 2. Maybe I should just bring the half up. So this is half x. Okay, this half, bring it out, will be multiplied by 2. This 1/5, bring it out, sine. Okay, then this will be 2e pi over 4, which is pi over 8, then minus e half multiplied by 0, which is e to the power 0. Then it will be sine pi over 10 sine 0, which is 0. All right, that's not an issue. I think what we need to do next is just this is 2e pi over 8, 2 times multiplied by 4 will be 8. E power 0 is 1. Okay, so I just put this as 1. All right, then this will be half minus 1/5. This will be sine pi over 2, which is 1. Then this is 0. Okay, sine pi, okay, maybe I just put this e0 because that's 2 e pi over 8. E to the power 0 is 1. This will be sine 90 degrees is 1 as well. Okay, so just remember that sine 90 degrees is 1. So then we just distribute this in 2e pi over 8 minus 2 minus 1/5. So key in calculator, should get the answer. In this case here, you'll get is 2e pi over 8 minus 11 over 5 square units. Okay, so that's how we do this question here. So let's look at this question here. Differentiate x ln x minus 2x with respect to x, simplifying your answer. So I think it's pretty okay, dx. The first thing is just to do a product rule for the x ln x here. I'm going to group it up for you. This is my u, this is my v. So essentially, keep the one on the left, so u, differentiate the one on the right, then keep the one on the right, differentiate the one on the left, then minus 2, right? So this case here, what I'm getting is this is u dv dx plus v du dx. Okay, so once done, this case here, what we get is 1 plus ln x minus 2. So simplifying our answer will be ln x minus 1. All right. So let's look at part B. So given that the second derivative is this and dy dx is given by k, these are all in terms of x. So meaning to say this is like a constant, it's already calculated out, right? So you can't really integrate this. So it's actually at the point. So it's given at when x equals to e, the gradient is this, all right? So using in part A, find the exact equation of the curve. And it's pretty okay. What we need to do is just find dy dx first. So d square y dx square is given by, I'm gonna just separate this 1 over root x. Maybe I could just square top and bottom. Okay, so this be x plus 1 square over square root x square. Is x squared plus 2x plus 1 over x. So simplifying this expression here will give us x squared over x plus 2x over x plus 1 over x. All right, then d square y dx square can be simplified as x plus 2 plus 1 over x. Okay, that's the first thing. Then once I've done that, I could start integrating. So dy dx will be integrating this expression here, dx, and once we're done, I know that this is x squared over 2 plus 2x plus ln x plus c. Okay, this is interesting. Okay, so this part is interesting because from the previous part, what we know that is that from the part A, okay, just take note is that we need to use this expression here. We know that from part A, if we were to differentiate this, we will get the this, right? We differentiate this, we'll get this. So meaning to say, so from part 1, just take note from 1. What we know is A, from A, what we know is integrating ln x minus 1 dx will give us x ln x minus 2x. Right, so that's the first thing. So because you can see, I can see the ln x there. This is the thing that we need to take note. So anyway, once done, this part here, I know that when x is equals to e, so when x equals to e, y equals to e cubed 6 plus e squared dy dx equals to e squared 2 plus 2e. Okay, so in other words, I'm going to just replace dy dx into this expression here, then replace my x inside here. Okay, just replace it in, and this replace it in. So what we get is from here, we'll get e squared 2 plus 2e is equals to e squared 2 plus 2e plus ln e plus c. Okay, ln e is 1. Right, ln e is 1. Then this case here, what we can do is just be minus off, and what we'll get next is 1 plus c is 0. So c is equal to negative 1. So in other words, dy dx now we can solve it as x squared 2 plus 2x plus ln x minus 1. Okay, so I could see that, like from the first part, we know that integrating ln x minus 1 will be x ln x minus 2x. So I could use the first part there. So y in this case here will be the integral of x squared over 2 plus 2x plus ln x minus 1 dx. From here, what we need to do is we need to solve out y. So I'm going to separate this to 2x dx plus ln x minus 1 dx. So this is from part A. From A, what we know is this integration here, ln x minus 1 is x ln x minus 2x. Then this over here is x cubed over 2 times 3. From A will be x ln x minus 2x plus d y. Alright, so now we can solve for our d. That is the important thing. So I'm going to solve for our d. In this case here, what I'll get is, we copy this, will be y is equals to x cubed over 6, 3 times 2 is 6, plus x squared plus x ln x minus 2x plus d. Then what we need to do next is just replace x equals to e, y equals to e cubed over 6 plus e squared. Then this will be e cubed 6 plus e squared. We just need to solve for the d. E cubed 6 plus e squared plus e ln e, which is 1 minus 2e plus d. Okay, so these two we could cancel away. These two we could cancel away. Ln e is actually just 1. So e, this is 1. This is 1. Okay, then e minus 2e plus d, 0. So this will be e. So d will just be a negative e. Oh, sorry, this is minus e. So this is plus e, right? So this case here, hence, y will be 1 over 6x cubed plus x squared. So I just replace my d back in. So plus dx ln x minus 2x plus e. Okay, so that's how you do this question here. Let's look at the next part. We have come to the end of our paper. Thank you for watching, and please remember to like this video and share this video with your friends if you find this video helpful. Remember to subscribe to our channel for future videos like this. And if you do need additional help, please do check out our IGCSE online math courses where students and teachers could learn in a safe environment. I personally will answer many of the students' questions there. Do check out the free mini course before signing up for the actual full course, where you can experience learning math in a holistic manner. So I'll see you online and see you in the next video.